We've already looked at what is a proportion. We know a proportion is what happens when you state that two ratios are equal. So a proportion is like A over B equals C over D. That's a proportion. We're going to look at about 5 properties here of proportions. And mainly they are, what can we do with this ratio, these two ratios, to still form the same proportion that this is? Now the first property I would like to look at is the means extremes property. The means extremes property in order to think about what are the means and what are the extremes, we have to write our proportion in this form. A is to B as C is to D. Let me try a colon there. Then the means are B and C. The extremes are A and D. In a proportion, the means are always the values right here, the B and the C. The extremes are always the values on the outside. If we think about what is the word mean, we use it in math to mean an average or the middle, right? So here we have the means are these numbers that are in the middle. Those are the means. Now we think, okay, what does the word extreme mean? Well, if someone does extreme sports, they are doing the sport, but they're on the very outside cutting edge of the sport, right? They're on the outside edge, you might say, of that sport. Okay? So these numbers that are on the outside are then the extremes. Now, let's go ahead and come back to our more traditional way of writing a proportion. A is to B as C is to D. And let's re-identify what are the means and what are the extremes. The means are B and C. The means are those. Those are the means. The extremes then are A and D. Notice that the means and the extremes are positioned diagonally from each other, right? So let's go ahead now and use a little algebra on this proportion. A is to B as C is to D. And the algebra I'm going to use is I'm going to multiply on both sides by the denominators. Can you see what I'm saying here? Okay. So I'm going to multiply by B and D. I'm multiplying by B and D over 1, which means what we are going to have here, the B's will reduce, leaving D times A. I'll put it A times D. Multiplication's commutative, it doesn't matter the order. And the D's will reduce here, leaving C times B, and I'll put it as B times C. Just keeping alphabetical. Usually when you write products, you write alphabetical. No reason. Just this multiplication's commutative, you can put it in any order. If you take a look at what we have here now, A times D equals B times C, and then you take a look at our means and our extremes, what you see is the product of the extremes equals the product of the means. A times D are your extremes. B times C are your means. So the means extremes property is the property that says the product of the extremes equals the product of the means.
That leaves A and C.
Right. A times D equals B times C. If we work with a couple fractions, you can see this even more clear. I know that 3/2 is equal to 6/4. If we use our means extremes property, we will multiply 3 times 4 and get 12. And then we will multiply 2 times 6 and also get 12. And you will notice that the product of the means will equal the product of the extremes. We can also say that we just cross multiply. So another way to refer to the means extremes property is to say we cross multiply. We can tell if two proportions are equivalent if we will use the means extremes property on both of them. So the means extremes property for A is to B as C is to D, A is to B as C is to D. When we use the means extremes property, we get A times D, and I don't want an equal sign, so let me put a little arrow there instead of equal. Okay. A times D equals B times C. This is what my means extremes property. Okay. Well, what other ways can I write this proportion and still get the same means extremes property now is the question. Because if I can write the proportion in another way and still get the same means extremes property, then I'm really using the same proportion. Proportions are equivalent when they have the same means extremes property. Proportions are equivalent when the means extremes property is the same. So again, the question, how can I rearrange this proportion? The trick really is if you keep the same direction. So what do I mean by that? Well, if I decided to rewrite my proportions with both of these fractions going from, instead of A to B, flipping them, so it's B to A, but I do the same thing on this. So I take these arrows and I flip their direction. I have to do both of them the opposite direction, okay? Which means if I go B is to A as D is to C, and then I check my means extremes property, I end up with, here's my arrow showing what I end up with. B times C equals A times D. A times D equals B times C.
Oh, you
A times, yep.
that equals,
Notice A times D,
yeah,
this product
yeah,
equals this product, right?
yeah.
A times D equals B times C.
Equals.
I get the same means extremes property in both cases, don't I?
Then the equal sign is like a line.
Oh, this thing right here?
Correct.
This thing?
Correct. Equals, just a flat equal sign.
Oh, this is an arrow?
Oh.
Yeah. Okay. So that means that I can flip both of them. That's a next property. If A is to B as C is to D, then B is to A as D is to C. And our goal is again to find more proportions. So what I'm going to do is take these little arrows and I think I can anyway. There we go. Move them so they're both going the same direction. Let's go. A is to C as B is to D. Check my means extremes property. Means extremes. There's my little arrow again. Okay. A times D equals B times C. Again, A times D and B times C. I get the same means extremes property, so again, this proportion is equivalent. So, here we are, property number 3. If A is to B as C is to D, then, and I would go A is to C as B is to D. So keeping that idea of being able to move the same direction each time and still get a proportion that is equivalent, what is another way that we could use these arrows and come up with another proportion that's equivalent? Who thinks they can come up with another proportion that is equivalent to this? Just take those arrows and point them a different direction, right? So what's another proportion you can come up with that's equivalent? You said what? DB, but not AC. Keep the order the same. CA, right? So we could go D is to B as C is to A. Again, you can check your means extremes property and you end up with the same means extremes property. Okay, so that's the general idea of how do you arrive at a proportion that means the same thing as this proportion. Okay. Now, our next property. And what it says is, if you are working with same proportion, A is to B as C is to D, then what you can do is add the denominator each time to the numerator. So the denominator of this first fraction is b, so I would have a plus b will be to b as, now I take this denominator and add it to the numerator of that fraction. So as c plus d is to d. Okay. It says that is also the same thing as a is to b as c is to d. Now in order for this to be the case,
A plus B is equal to B.
if I use the means extremes property on this,
How does that work?
that's what we're going to be looking at. And there's two ways I could show you why it works, but no, it's because you can write this as two separate fractions, and I'll show you this way first. A over b plus b over b. That's the same thing as this right here. No, keep watching. And this is the same thing as c over d plus d over d. That's the same thing as this,
Yep.
right? And b over b is equal to 1. D over d is also equal to 1. So it's just adding a 1 to both sides of this fraction. And I should say plus 1, and I started writing 2 steps ahead. Let me try again. A is to b plus 1. Okay. It's just adding 1 to both sides of those fractions. Which means if you subtract that 1 now from both sides, you get the A is to B as C is to D. Okay. Now, you can also use your means extremes property, because what we have decided is if your means extremes property gives you the same thing in both cases, then you're working with an equivalent proportion. So, using my means extremes property, I would end up with d times a plus b equals b times c plus d. When I distribute, I get AD plus BD equals, and then I distribute here, give me BC plus BD. Notice the BDs are on both sides, so I can subtract that from both sides, leaving AD equals BC, which is what my means extremes property is right there. So now, our last property here of proportions is another interesting one. Trying to find room to write it here. Property number 5 is another interesting one. If you have several proportions, so A is to B, as C is to D, as E is to F, as G is to H, and we can continue this as long as we wanted to. Then, if you add all of the numerators, A plus C plus E plus G plus, and however far we continued it, and you add all the denominators, B plus D plus F plus H plus however far you continue that. Okay? Then that would equal, in fact, your original ratio. it would equal either A over B or C over D or E over F or G over H, any one of them, because they're all equal. Okay? So it would equal A over B. That's where we'll go with that. That's our last property of proportions. Now the question would again be, why? Why is this? So taking a look at the means extremes property of all of these with A over B. So A is to B as C is to D, compared to A is to B as E is to F, compared to A is to B as G is to H. And when we look at the means extremes property for all of these, this one yields A times D equals B times C, like we've been working with. This one yields A times F equals B times E. This one yields A times H equals B times G. Doing means extremes property. Those are just cross multiplying, right? Okay, that's all I've done here. Those are just looked up. Alright? So now, doing the means extremes property for this piece, the right-hand piece here, I would have B times A plus C plus E plus G and that will equal A times the denominator here.
Equals 0.
Not this time, it's just equals. This piece right here though, arrow this piece, right? Equals this piece. Means extremes property. When I distribute the B in, I get AB plus BC plus BE plus BG equals, and then I get AB plus AD plus AF plus AH, and on both of them I have the dot dot dot, just for that. Well, what I know is that AD equals BC. So I have BC, I have AD. Right? I know that AF equals BE. So here I have AF and BE. So I have AF and BE. Those are equal. I know that AH equals BG. So AH and BG. And AB equals AB. So these are equal to each other, using your means extremes property for all of these proportions. Okay? Which means that this sum right here, where you add all of the numerators of these fractions and add all of the denominators of these fractions, will equal this right here, because our means extremes property is true. Okay? So now, using these properties, I wish I knew why sometimes it just chose to not do what I asked it to do.
Maybe it doesn't like geometry.
Okay, Got it. So I have my properties here. There we go. Using these properties. First off, the last one's kind of interesting. Let's work with the last one. Bar. Maybe I should put that away. Okay. If I have two similar figures, so let me draw a figure. This is one reason why I love the smartboard, is because no matter what kind of crazy figure I draw, I can always create a figure that's similar to that by just cloning. Oh, I love to cheat. Okay, so I have two similar figures here. Now, if these figures are similar, then all their corresponding parts will be in proportion, which is what we're going to look at in the next section. Okay? But what that means is, let's say I enlarge this one times 2. So if this is 2, then this is 4. Right? If this is 4, this is 8. And I can do that all the way around. So I have 4, 6, 5, 5, and 4. Which means this is going to be 8, 12, 10, 5, and 8. Or sorry, 10, 10, and 8. What this last property tells me is if I find the perimeter, notice I could write all of these as ratios. 2 is to 4 as 4 is to 8. As 4 is to 8, as 6 is to 12, as 5 is to 10, as 5 is to 10, as 4 is to 8. That is using all these sides in proportion, with the equal side in between all of them. What this last property of proportions tells me is if I add all of these numerators or find the perimeter of this first figure, then I will have 10 plus 11, 21 plus 9, 30. And if I add all of the perimeter of this larger figure, which is adding all these denominators, so this is going to be 12 plus 8 is 20, plus 22 is 42, plus 18 is 60. And then I compare the ratio of the sum of the numerators to the sum of the denominators. I have 30 over 60, and that will equal the ratio of two sides, which 2 to 4 was my first fraction here. That will equal 2 to 4. It will have the same ratio. The ratio of the perimeters will be the same as the ratio of the sides. Okay? And yes, that is a 1 to 2 ratio. That's what the last property of proportion tells us. Okay. Now, working with one example problem before I turn this recording on. There, got it. If you take a look with me at page 247, number 19. Number 19, I have proportion. 7 is to 6x minus 4 as 9 is to 4x plus 6. The process you always use to solve proportions is the means extrudes property, which is cross multiplication. So, the process I'm going to use to solve this set of proportions is take 7 times the 4x plus 6, do that cross product, and then take 9 times 6x minus 4, do that cross product. Now I have an equation that is easier to solve. So when you're solving a proportion, what are you always going to do, Branson?
Cross multiply.
Cross multiply. Thank you, Destin. Cross multiply. Now let's continue this. So I have 7 times all of these, which is going to be 28x plus 42. And then I have 9 times all of those, which is going to be 54x minus 36. And I get my x's together, which is going to be subtract 28x. That will give me a total of 26x, I believe. I did that correct. Get my numbers together, so add 36. On the other side of the equation. So I'm going to end up with 78. And then get my epsilon by divided by 26. And I will end up with x equals. And then I think, okay, what does this go into? And you can help me out there with your calculator. 13 goes into 26. Does 13 go into 78?
Yeah.
Anyway, x equals 3. Thank you.
Oops.